Welcome to my channel. So we'll continue the voltage to current converters. There is a need to measure 6 volts to 10 volts. The available voltmeter range is 0 to 6 volts what you have in hand. Is there any solution for this? How you do it? Just take a minute, try to think or try to write down in your notebook. Pause the video here. Hope you might have written. We have already discussed V to I converter in the part 1 of this video. RL can be replaced by D-Arsenal meter with a full scale deflection of 1 milliammeter. What is the meaning? Whenever 1 milliammeter current flows, it will show you the full scale deflection. So that figure with a meter is shown in the next slide. This is a low voltage DC voltmeter. This is what we told. Instead of RL, we are connecting this D-Arsenal meter. A full scale deflection occurs when a 1 milliammeter current flows, and these are the different resistors we have connected, and it is a rotary switch. We have offset voltage compensating network, and see this complete circuit. Take a minute and pause here. Now, external offset compensating network is basically used to null the output. This we have discussed in the previous videos. Now this particular resistors 5K, 15K, 10K, these are used to null the output. So in this, what might be the resistance between the A and B? Between the A and B. Take a minute and try to find out. Pause the video here. Try to find out. This is a 10 ohm which will come in parallel with a 15K plus something will get based on the position. 15K plus parallel comes with a 10 ohm. What is the resultant resistance? Yes, it should be nearly equal to 10 ohms. Now, in this, if I consider this particular path, I have a 1 kilo ohm plus, just now you have discussed, it will be 10 ohm, whatever you have taken complete this compensating network. And if Vin equal to 1 volt, then I naught equal to Vin by R1. Therefore, I naught becomes how much? 1 volt divided by 1 kilo ohm, it will become 1 milliamps. This equation I have discussed already in the part 1. Now, when 1 milliamps flows, the deflection will be full. This means that 1 volt causes the full scale deflection of an ammeter. So if it is a half, then automatically 50% deflection will be there. If a range switches to a 10, the total resistance will become how much? 10 kilo ohm, what we have, plus 10 ohm, what we get. So it's approximately equal to 10 kilo ohm only. Now, it will require 10 volts input here, so that you will get a 1 milliamps current, so that full scale deflection will be there. And higher resistance values are required to measure the higher input voltage. So basically, when 1 volt was there, 1 kilo ohm, and 10 volts, 10 kilo ohm for a full deflection. Similarly, 20K is used to measure the 20 volts. Yes or no? Think on this. Input voltage I told 20 volts, but supply voltage itself is 15 volts. Maximum input voltage what we can give should be less than or equal to 14 volts. Hence, up to 13 it is shown in this particular diagram. So use your common sense and try to understand. DC voltmeter with a full scale deflection, a range of 1 to 13 volts can be constructed, not up to 20, because supply voltage is 15 volts. So meter resistance do not affect the I naught. So this resistance does not affect the I naught. The reference what you have taken is Ramakant Gaikwad, and for more information visit these links. Thanks for watching this video, and share this video if you like, and subscribe this channel. Thank you.